Since all the rules are the same for solving equations, other than the addition of if you multiply or divide by a negative number, you must switch the direction of the inequality sign. I figured I'd give you kind of a tricky problem here. I'm going to say something like this. I'm going to say 11 take away 3y all over negative 4 is greater than 2. Let's see what happens on this problem. First off, we've talked about having complex fractions. We've got two parts in the numerator. We can't just move one of those terms. You have to get rid of that denominator. These married terms have to be divorced. So we're going to get rid of that negative 4. Our first step is to multiply both sides by negative 4. Now, of course, if you multiply by a negative 4, you're going to have to switch the direction of the inequality sign. So here, the negative 4's cancel out. Numerators come down unchanged, as always. Because I'm multiplying by the negative, that forces this greater than to become a less than. And yes, you need to be able to pronounce these. If it points to the right, it's greater than. If it points to the left, it's less than. Left, less than. I almost see an L there. That's how I remember it. It looks like an L, so it has to be less than. And then, of course, negative 4 times 2 is negative 8. Because we multiplied by a negative, we switch the direction of our inequality. Now, if you leave that variable on the left-hand side, we're going to want to get the 11 out of there. We'll say negative 3y is less than negative 8. Now, the 11 comes over. It's positive here, so it comes over as a negative 11. And so we can say negative 3y is less than negative 19. And then we'll divide both sides by negative 3. Divide by negative 3. Divide both sides by negative 3. I'm thinking multiplying, dividing by a negative. Here's a clear case. You're dividing both sides by a negative. So once again, we're going to have to switch the direction of that inequality. And we'll say y is now greater than. You can throw that in your calculator. It should be 6 1/3, I believe. And so then we want to turn this into set building notation. Again, I like to cheat. I'm lazy. Since the y is already there, I just add the line there and this y. It again is read as y, the set y, such that all y values are greater than 6 1/3. Put the brackets around. The brackets represent that there's an infinite number of solutions, and we reinforce the idea simply by graphing. Here's my 0. I know that 6 1/3 is found to the right. Open or close circle. Open, because it is a strict inequality. And it tells me which way to shade, so I shade. Oh yeah, there it is. Good answer.